hope you are enjoying the conference so far. Yeah, okay, well, thank you. So, I'm Thomas. I'm from Italy, as you can hear from my accent, more specifically from Udine, so not that far. You can find me almost everywhere with @Delvedor. This is my GitHub account. As you can see, I'm doing quite a lot of open source. I work for a company called Elastic. You may know us for the Elasticsearch database, Logstash, Kibana, so many other cool things. But today I'm not here for talking to you about Elastic. I'm here for talking about a super great idea that I want to share with you. Then I started thinking about this a few months ago, and now I am searching for people to help me build this new disruptive startup. So let's start together. So the next $1 million startup will be Moo. Basically, the idea is to have Twitter with more charters and cows. So I already know that we'll be super rich by the end of the month. A user should be able to obviously sign up. We need the users. Post a new Moo, get a post by ID, search a post, obviously, and finally get to the post of a user. Well, our startup will expose 3 different services to handle all this super load of people. So there will be login, post, and user. These more or less are the routes we will build: sign up, post, the ID, searching endpoint, create endpoint, and finally fetch by username endpoint. For building this new amazing product, we will use this framework. The name is Fastify. How many of you here already heard Fastify? Wow, that's amazing. Well, for who doesn't know, Fastify is a HTTP web framework for Node, not yet another. This is a good one, I hope. And I started building this framework 2 years ago with Matteo, who is here. It was September 2016. As the name suggests, the idea is that this framework should be very fast. And currently, we are keeping with this concept. This is a very, very simple Hello World example, just to show you the API. It's very, very close to Express or Happy. So if you are using one of them, it's very easy to go to Fastify. And why this name? Because these are currently our benchmarks with Node 10 on an AWS machine. Node Core is about 43,000 requests per second, Fastify 40, Happy, Restify, and Express under 30. So we are more close to Node Core than all the others, which is not that bad. I have to say today, 2 years after the name Fastify is a little bit of a curse, but we are keeping the speed for now. So a little bit of configuration for our project. You know, if you are building a microservices system, you probably will have many teams, different code conventions, different way to create directories, files, testing, almost everything. So for helping you with this, we have built a powerful CLI, I hope. You can install it with npx fastify generate and the name of your project, then go inside your directory and install everything. Inside that directory, we'll find this stuff here, the app.js, which is your application entry point. Here we'll load all your dependencies, your routes, basically everything. Then a services folder, where you declare all your endpoints, a plugin folder, which as the name suggests, all your plugins, and finally, a test folder. Well, guess what? All your tests. We give you out of the box 3 scripts: npm start, which starts your application; npm run dev, which will start your server with pretty logs. Please do not use it on production, otherwise Fastify will become slowify very, very quickly. And finally, obviously, npm test. So let's start. Let's take a look at our monolith. This talk we have many demos, so please light up a candle in the demo God's temple for me, and let's hope that everything works. So let's bring up everything. Oh, perfect. First one, demo gods. So let's take a look at our code. Spoiler alert. OK, this is our folder, as I told you. This is our entry point. We work a lot with promises. So And if you are doing this, please use this nice module, make promises safe. It will make your life way easier, believe me, I know. Then here we are declaring our entry point. As I was saying, we are registering a plugin, which is Fastify Sensible. If you are a VI user, you may notice some naming conventions here, and which basically will add some nice utilities to our code. Then a database connector, which obviously would be Fastify Elasticsearch. Then bcrypt for everything crypto. And finally, basic out. For the purpose of this demo, I will not use HTTPS. So we will use basic out over plain HTTP because I really like to live in dangerous situations. And then how works the validation function is very easy. We are searching for the user in the database. If he is not present, we are sending back a 401. Everyone can see the code? Perfect. Sending back a 401. Otherwise, we will compare the hashed password. If it's not valid 401, otherwise we can continue with the request. Then we have these two very nice auto-load plugins, which basically will automatically load the entire content of the plugins and services folder for you. And so let's take a look to our services folder. As you can see, it's already divided by all the services that I showed you a few seconds ago. So let's take a look at the first one, the login. Here we are exporting a function which takes two parameters, the Fastify instance and a bunch of options. Here we are getting out of Fastify few utilities, the assertion, the Elasticsearch connector, and bcrypt. This is a route declaration in the happy style, if you do not like Express. Method post, URL sign up. Then there is this very nice schema thing. Fastify uses a lot JSON schema for validating stuff. How many of you know what is JSON schema? Amazing. For who doesn't know, basically JSON schema is a JSON file, obviously, which defines the shape of the object that you expect. So you declare, for example, your properties, the type of your properties, and a bunch of other validation things. This is definitely not a JSON, it's a string, because it's a pointer to the Fastify registry of all the JSON schema, and we'll show you in a moment. And finally, this is our sign-up function. So what we are doing here, we are getting for the body username and password, quite easy until here. Searching the database if that username will already exist, if so, for 100 error. Otherwise, hash the password. You should always hash the passwords, please do it. And then we index the new user in the database. Finally, we send back a 201 to our clients. As you can see in the configuration of the query, I added this very nice parameter, which is refresh wait for. If you are using Elasticsearch and you want to be sure that the data is on disk before people start asking for it, you should use this property, which basically will wait that the data is actually on disk before sending back a response. And then here I'm also sending back the basic authentication out code because I'm very, very lazy. I don't want to craft it every time. Then we have our post endpoints. Here we have, again, the Elasticsearch endpoint, HyperID, which is a very nice module for generating unique IDs very, very quickly. I highly recommend it. And the post ID search. As you can see here, again, we have all our schema definition. Here we are searching for the post ID, so we should validate that it's a string with a specific length and so on. And the valid response should be the object that represents a mu. So this is the search, very easy, we search by ID. Then this is the actual full text search for our API. Again, it's very, very easy. Here we are validating the query string, and more specifically, I will show you in a moment, we are searching for the search value inside the query string. If it's not present, we will send back a 401, sorry, a 400. And then we are sending back an array of mu objects. How that works? Quite easily. We just call the database and search for our text insider. And finally, we have our post creation. This is a little bit bigger. We are searching the headers in the username, inside the headers, because our basic out is handling that for us. And inside the body, we have the text the user have just passed. So how it works, we just get the text, the author, we get the timestamp for the time, an ID we generate on the fly, and then we save everything on the database. And last but not least, our amazing user service. I forgot to say that before. As you can see on line 6, there is this very nice pre-handler hook, which basically allows you to run a given function, an array of functions, before your actual user handler, so before this one, to be specific. And in this case, we are handling the authentications. So basically, every route we will declare inside this function will be protected by the basic authentication thing. How works the search is, again, a very, very basic query to the database, and we search by username and sending back the data to our user. So, quick look to the plugins folder. This is the schema registry I was saying you before. We have this very nice API add schema. We configure an ID that will be used around later. And in this case, this is the validation for user requests when you are creating a new account. So we expect to have username and password defined because they are required. They both need to be strings with a little bit of validation inside. Let's see if there's interesting here. OK, this is the post response that you already saw a few times right now. So ID, text, time, everything should be a string except the timestamp. So let's see if everything works. The database is up. Let's run our server. OK, nice logs, colorful one. To be sure to not do too much typos, I create a very, very nice make file with all the requests already crafted. So I'm not trying to print already prepared responses. Everything is working. Believe me. So let's create a user. Create user, Tomas, password, very secret one. Have to wait a little for the refresh thing to happen. That's our user. Let's now create a new post. So hello, Node.js config. It's working. That's it. This is our ID. Let's get now that post. Oops. Oops. Sorry. OK, that worked. And now let's get all the posts of a user. So Thomas. And it's an array of responses. So everything is working right now. Oof, very good. So let's kill everything. Going back to us. So what we have just seen can be summed up in this very, very nice image. Basically, we have our entry point, which register all our services, login, post, and user. As you can see, the project is already divided in logical areas. This is what we try to enforce with Fastify. And so, fast forward 1 month, we have 1 billion users. We are super, super under heavy requests. So we should figure out a way to move our architecture to something more elastic. And why not use microservices, this very nice buzzword. So before showing you how we will do that, a very, very quick recap about Monolith vs microservices. I'm sure everybody of you knows the difference. So what I want you to remember right now is that in the Monolith, we have all the code base in the same place. The deployment is every time all together. And very, very often you have some mixed logic, awful cross-dependencies, some nasty thing like that. While the microservice architecture, everything is nicely divided by logical pieces, everything is independent deployable, and so on and so forth. Usual story. So how can Fastify help you move from a monolith to a microservices architecture? Well, there is this feature that, in my opinion, is way better than the speed of the framework, which are Fastify plugins. We spent like 4 or 5 months destroying our code base every day, trying to figure out which was the best way to handle this. And this is how it works. This is one unique API for register a plugin, which is register. You already saw that. The first parameter is your actual plugin. The second one is a bunch of options, which is definitely not required. Then what is a plugin? A plugin is just a function that takes 3 parameters, or 2, depends if you are using a sync await, which are Fastify, an option object, and next. The next function, basically, you have always to call that, is mandatory, because Fastify guarantees you the loading order for your entire application. It will not boot up until everything is ready to go. Inside the plugin, you could do whatever you want. You can register another plugin, add a hook, a decorator, a route, whatever you want, really. So, oh, that's nice. Okay. How is the architecture of the plugins on a very, very high level? We have, let's say we have our entry point, which registers 2 plugins, 1 and 2. And then plugin 2 that is registering plugin 3. It's very easy, super easy to understand. So let's say now we want to add a new feature in one of our plugins. For doing that, with Fastify, you have to use the decorate API, which will add this API to the Fastify instance. And let's say we are adding to plugin 2. The problem with Monolith that when you add something, you start using like everywhere. It's like a hill. You start to spread across your code base, and when the time comes to split a microservice architecture, it will be super hard because cross-dependencies mix a logic again. So the plugin architecture of Fastify enforces encapsulation. What does this mean? This means that if you are decorating the Fastify instance inside the plugin 2, you will have this brand new API only inside plugin 2 and its children, not inside the parent. Can you see that magic? It's very cool, believe me. It's very cool because when the time arrives to split your application, you have just to duplicate your entry point, remove plugin 1 and plugin 2, and you're done. Microservices. So let's say there are a few cases where you may want to expose a functionality to a parent. Let's say you are adding a database connector, so it will be nice expose it to the rest of your application. For doing that, there is this module, Fastify plugin. Sorry, there are so many plugins in this talk. Again, we have our function. We are adding a utility, so with decorate, so you can access it with fastify.util. And then when arrives the time to export it, we just wrap the plugin with Fastify plugin. So what happens? It happens that now also the parent can access all the APIs that plugin 2 is adding to our instance. Which in the real world, as said, can be a database connector. You are using Fastify plugin inside the database connector, you're registering inside your entry point, and now your database connector will be available in the application because you are registering inside the entry point. So all the children will have that API. The encapsulation enables also other very, very nice thing. One of my favorite is the custom log level per plugin. This means that, let's say you have 2 versions for the same API, 1 and 2. Version 1 is very settled, everything's working, no worries about that. So we choose to put the log level at error. We just want to know if something went wrong. While the version 2 is under heavy development, so many breaking changes, so many terrible stuff, so why not use debug as a log level? This is fully supported, just 1 logger, so you don't need 2 loggers, and internally we handle everything. Then you can see there is also this prefix option, which basically will add that prefix into all the routes declared inside this plugin, which can be very useful if you are lazy like me. So, if you have to remember something about all this story, is that in Fastify, everything is a plugin, literally everything. So, sorry, I will continue to say this word a lot. So, let's move from monolith to microservices. Demo time again. Let's open everything. So what I did, as I anticipated you before, I basically duplicated 2 times our monolith and renamed the folders. And then I removed all the code that was no longer needed from every service. For example, if I open the login one, as you can see, the folder structure is exactly the same. But if I open the services folder, there will be only the login file, okay? Believe me, I did not any other change in the code, any other notable change. Here, for example, I just removed the authentication logic because it was not needed. But if I open the login project, you will see that is absolutely the same code as before. There was no required changes at all. And if you don't believe me, we can open also all the other services. Again, everything is working exactly as before. And to showing you that, I can try again to create a new user. This time I have to add the the port to my command because our services are listening on different ports, obviously. So let's create the user. Yeah, it worked. Let's create a post, which is a completely different service. Port 3031, I guess. I hope so. Yup. And now let's get everything else, which was port 3032. Yeah, everything is working. Great. So this is our current situation. We duplicated the project, we removed all the code that was no longer needed, and as you can see, we have almost the same code as before, same structure, just 3 different entry points. So basically, what we have to do now is to tell to all of our clients to update their logic in a way that they will know which address to call based on the API they need. No, we should not do that, right? It's not that good of an idea. So the infrastructure should always be transparent to the client. The client, if you are using a monolith or a 1 billion microservices, the client will never know this. So how can we fix this? Come on, we are together in this startup. I need ideas. Proxy or? API gateway. Exactly, an API gateway. So we can easily use Nginx, HTTP proxy. There are a lot of them. But we are in the JavaScript world. If we can implement something with JavaScript, we will. So we have built Fastify HTTP proxy. Who will solve the issue for you. How it works is very, very easy. You just register the plugin, you set an upstream URL, and finally a prefix in a way that every route that will match this prefix here will be redirected to the upstream URL, and we are done. So, demo time again, other side. In the meantime, I can show you very, very quickly what I did. So, as you can see, the project structure here on the left is exactly the same as before. We have just added another folder, which is the gateway. And as you can see again, the structure is always the same. Consistency, very cool thing. And the app.js is absolutely the same as the one we did since the beginning. We are just Fastify sensible. The Elasticsearch connector, here I'm handling the case if it's Docker because I'm using different URLs, bcrypt, and all the authentication stuff. The only change that I did here was to completely remove the authentication logic for the various microservices because now the gateway is handling them for us. And inside the services folder, we'll have our 3 nice files, and every file have just the redirecting logic to the correct port based on the prefix. So before showing you the final demo, this is basically our infrastructure right now. We have the Elasticsearch service, the login services. As you can see, I'm not exposing anymore the port because our microservices are no longer protected by basic authentication. Ports, blah, blah, blah. And finally, our gateway that is connected to everything else. As you can see, you can set many things with the environment variables. For example, the port, the address to listening on, whatever you want. And this all thanks the Fastify CLI tool. So let's try to create a new user again. Let's remove the port because we don't need it anymore. We are listening on port 3000 somewhere over there. Yes, it worked. As you can see, there are way more logs right now. Basically, the gateway is logging that's in a new request, it's telling you which URL is using now, and then the login service will tell you all the other things that you need to know. So let's see now if the create endpoint was working. Git post, remove the port. Yes, it's working. And finally, the get all the user posts. Ta-da! It's working. Amazing. So this is our infrastructure now. Ooh, by the color choice. We have our gateway at the beginning of our application, then all of our other services. As you can see, almost nothing changed. We are just added a few more lines, a little bit more complexity on the deployment side. But that's the cost of microservices. And this was Fastify, and I really hope you have enjoyed. We have almost entirely built in Italy, so we must all be proud about that. And go to GitHub, drop a star. We are about to release in version 2, or the first release candidate will be out next week, probably. So please try it, give us feedbacks. We are definitely waiting for them. These are the URLs where you can find the entire presentation and all the code if you want to solve it a little bit. Thank you.